Assalamu alaikum. Good morning, respected teacher and students. Today I will present my assignment on computer organization and architecture. In this presentation, I will discuss the structure of a computer system, memory organization, instruction cycle, parallel processing, and more advanced concepts. Let's begin. Introduction. Before we go into details, let's start with an introduction. A computer is made of hardware and software working together. Computer organization tells us how different components like CPU, memory, and IO devices interact. Computer architectures focuses more on the design, speed, and performance improvements of the system. Basic structure. The basic structure of a computer has four main parts. The CPU is the brain that executes instructions. Memory is used to store both data and instructions. IO units are responsible for communication with external devices such as keyboard, screens, or networks. Finally, buses are like highways that transfers data between all components. Memory hierarchy. Memory is arranged in a hierarchy for efficiency. Registers are the fastest but very small, used by the CPU directly. Cache stores frequently accessed data to reduce delays. RAM is the main working memory where programs run. Disk is the slowest but provides large and cheap storage for long term use. Instruction execution. The CPU works in an instruction cycle. First, it fetches the instruction from memory, then it decodes the instruction to understand what needs to be done. After that, it executes the action such as calculation or data transfer. Finally, it stores the result back in memory. This cycle repeats millions of times per second. Parallel processing. Parallel processing means multiple processors working on different tasks at the same time. This reduces execution time and increases efficiency. For example, in a healthcare data platform, thousands of patient records can be processed simultaneously using parallel systems. Fault tolerant memory. Fault tolerant memory is designed to keep data safe during failures. Redundancy means multiple backups of the same data. Error detection and correction system find and fix errors. This is very important in critical systems like healthcare and banking, where data loss can be dangerous. High throughput IO. High high throughput IO makes sure that data enters and leaves the system quickly. This is important for real-time systems where large amount of data are processed continuously. For example, patient monitoring devices send continuous data that must be processed without delay. Applications. These components are used in many real world applications. In healthcare, they help monitor patients in real time. In banking, they ensure secure and fast transactions. AI and robotics use parallel processing for decision making. Cloud computing relies on memory hierarchy and fault tolerance to handle massive data. Conclusion. To conclude, a computer system is built from CPU, memory, IO, and buses. The memory hierarchy helps balance speed, cost, and storage. Parallel and fault tolerant systems are shaping the failure of computing. High throughput I/O ensures smooth real-time data handling. Thank you, everyone.